Hi, we had started our discussion on this new chapter on lines and angles. The first concept that we'll study under this chapter is known as pairs of angles. Okay, so let's start by talking about angles formed when a ray stands on a line. A ray standing on a line. Now what do we mean by this? Let us first draw a line. If you remember, a line was a one-dimensional figure which could be extended in both directions. Let me call this line AB. Alright. Then let's look at a ray which was standing on this line. So if this was point O and this is our ray OR, then OR is a ray which stands on this line. Now this ray could have been in any direction. That doesn't matter. Now if you look carefully, we'll see that there is a pair of angles that is being made here. Now the first angle that we can look at is angle AOR. This particular angle. Angle AOR. What's the other angle that's being made here? Yes, it's angle ROB. This one. R, O and B. So we see that there are two angles being made here. Hence, it's known as a pair of angles. Now let's look at an axiom. The axiom says that if a ray stands on a line, then the sum of the two adjacent angles thus formed is 180 degrees. Now let's see how this works out. So here in this figure above, we see that there's a line AB, and there's a ray OR which stands on this line AB here. The two angles formed are angle AOR and angle ROB. That is, angle 1 is angle AOR and angle 2 is angle ROB. If we look carefully, then angle 1 or this angle plus angle 2, that is this angle, forms the complete angle AOB. So I can say angle AOR plus angle ROB is nothing but the whole angle AOB. And we know that a line forms an angle of 180 degrees, right? Since this whole angle is 180 degrees, I can easily say that this thing is equal to 180 degrees, or angle 1 plus angle 2 is nothing but 180 degrees. So these are two adjacent angles that are formed, angle 1 and angle 2, and their sum is 180 degrees. That's what the first axiom has to say. Now we could also look at an inverse of this axiom. Let's see what that would be like. Let's say that there are two adjacent angles whose sum is 180 degree. So what would happen in that case? Let's first draw the figure as is customary with every geometry problem. Let's say that this is the first angle and this one here is the second angle. Now these are adjacent angles, as we can see. Why are they adjacent? Because they share one common vertex and they share a common arm. Let me just name them. So if this is P, this is Q here, let this be O again and let this be R. So we have two adjacent angles. One of them is angle POR, the other one is angle ROQ, right? So these are two adjacent angles. I also know that the sum of these two, angle 1 and angle 2, angle 1 plus angle 2, is given as 180 degrees. Now can I say something about these rays OP and OQ? Yes, I can say that these two rays OP and OQ are opposite to each other, and hence PQ forms a line. That's the inverse of the first axiom that we saw. So if two adjacent angles have a sum of 180 degrees, then their non-common arms would form a line. Let me write it down for you here. As I told you, it says if the sum of two adjacent angles is 180 degrees, then the non-common arms form a line. Let's look at an example for this. So if I say there are two adjacent angles, again adjacent means they have one arm in common, and let's say this angle is 120 degrees and this one is 60 degrees, then we could say that they have a sum of 180 degrees, right? Hence this right here would be a straight line. Great. Now these angles could have been 140 degrees and 40 degrees. Again the sum would have been 180 degrees, and this one here right here would have been a straight line. But what if the sum of two adjacent angles isn't 180 degrees? Say this is a 90 degree angle and the other adjacent angle here is a 45 degree angle. We see that the sum of these two values is 135 degrees, which is not equal to 180 degrees, right? And we also see that the non-common arms do not form a line. So only when the sum of the two adjacent angles would be equal to 180 degrees, that is when the non-common arms would form a line. Now that was that about axioms. Let's look at a theorem now. Now this theorem is about two angles formed by intersecting lines. Just now we saw two angles formed when a ray stands on a line. Now we'll talk of two intersecting lines. Let me just draw two intersecting lines. So let me call this one line L, and let me draw another line. Let's call this line M. I can represent lines by small letters, right? Okay. Let this be point A, the center one be point O, B, C and D. Now let's look at what the theorem has to say. So it says that if two lines intersect one another, then the vertically opposite angles are equal. Now first of all, let's understand what vertically opposite angles are. So in this figure, where two lines, line L and line M, are intersecting at point O, let's look at what vertically opposite angles would be. So angle AOD, this angle, as we can see, is directly opposite to angle BOC, isn't it? This one. So these two angles, angle AOD and angle BOC, are vertically opposite angles. Similarly, if we look at this angle, angle AOB, and also an angle opposite to it, directly opposite to it, that is angle DOC, this one, then they are also a pair of vertically opposite angles. So angle AOB and angle DOC. Now this is the first pair and this is the second pair of vertically opposite angles. Now the theorem says that when two lines intersect, the vertically opposite angles are equal. That just means angle AOD is always equal to angle BOC, and also angle AOB is equal to angle DOC in this particular figure on our left. So that means if this particular angle was 40 degrees, then this angle would also be 40 degrees, and this particular angle would have been 140 degrees, and also angle AOB would have been 140 degrees. Let's see if we can prove this theorem. First of all, let us consider line M. Line M. On line M, I can say that OB right here, OB looks like a ray. It does, right? So line M has ray OB standing on it. And as per the axioms that we just saw, angles AOB plus angle BOC is nothing but a linear pair of angles, and hence their sum is 180 degrees. Let me call this equation A. If you look at the values that I assumed here, then also you can see that 140 plus 40 would have been 180 degrees. But these are just values that I took for examples and not the real values of these angles. So I have just said that angle AOB, let me call this angle 1, plus angle BOC, let's call this angle 2. So angle 1 plus angle 2 is 180 degrees because there's a ray OB standing on line M. Let us now consider line L. So this one, the red one, is our line L. Also, let me say that OC is a ray which stands on this line L. So OC is a ray which stands on this line L. And as per our axiom, we would have this one, angle BOC, plus angle COD. This is the other one, angle COD, as 180 degrees. Let this be equation B. So if I name angle DOC or COD as angle 3, then I am just saying angle 2 plus angle 3 is also 180 degrees. If you look at the right hand sides of both these equations, equation A and equation B, we see that both of them are equal to 180 degrees. Hence, we can just equate the left hand sides. So that would give us angle AOB plus angle BOC equal to angle BOC plus angle COD, right? And on both sides I have this angle BOC which could be cancelled out, and what I would be left with is angle AOB is equal to angle COD, which basically means angle 1 is equal to angle 3, and that is nothing but this particular condition right here. So we've just proven that angle AOB is equal to angle DOC or angle COD as I have written in this case. So the vertically opposite angles are actually equal. I could have proved this condition 1 as well if I had considered OA as a ray on this line L and gotten another condition involving angle AOD, this one, angle 4. Then I would have proved this part as well. I would suggest you try that by yourself. It'll be fun. I'm really enjoying this chapter on lines and angles. Let's see if geometry is actually as much fun as I say it is. I'll see you when we solve certain examples on these. Bye.